Testing 1, 2, 3. Testing 1. Hello, everyone, and welcome to Branched Oak Observatory's live feed of the 2020 conjunction of Jupiter and Saturn. We are indeed live. Hopefully, the feed over YouTube is working for you. If not, you can just turn down the volume and enjoy the video that does come in. We are actually in the Bowler Civil Observatory at Branched Oak Observatory Sky Park, and we are observing planets Jupiter and Saturn at a very high magnification here. You can see them moving around a little bit. That's from the atmospheric refraction, and then also just a little bit of wind is moving the telescope around a little bit. We are looking through what is this, a 2,800 millimeter focal length, 11-inch Schmidt-Cassegrain telescope. You'll have to forgive the poor imagery here. This is a live view. It's not a stacked or processed image. Also, with the planets as low as they are above the horizon, we are getting a good deal of atmospheric refraction, which is, of course, compounded by our high magnification. If you have a telescope, It most likely has a lower, uh, much smaller, shorter focal length, and you will get a more appealing uh, view through that if you have a telescope available. This brings us to an important recommendation, and that is if you have not already taken a look at the pair with the unaided eye, please go outside. It's important that you see this with the unencumbered eye live with your own eye. Let those photons hit your pupil. And don't be surprised if you tear up just a little bit. Sometimes seeing nature's celestial dance can do that. And it's common with eclipses, planetary transits, and maybe even great conjunctions, just like this one. Oh, look at this. I've got a special guest. This is Mama Cat. This is one of our many kitties out here at the observatory. She's looking for a little food. I was eating a ham sandwich here the other night, and she was really happy with that. So again, if you haven't already, go on outside, take a look. Saturn may be difficult to resolve at first, particularly if it's not extremely dark yet. It's not looking too bad out there. But if you look very closely, you will see the fainter star-like object to the upper right. Jupiter right now is 11 times brighter than Saturn. So Saturn will be lost in the glare at first, but take a look closely and you will be able to see both Jupiter and Saturn right next to each other, as you can see in this video. Like I said, the video quality may not be absolutely wonderful here, but you are able to see the rings of Saturn there. And every once in a while, when the atmosphere cooperates with us, you're able to see maybe some cloud belts there on Jupiter. If you have your own telescope, or if you have a good pair of binoculars, you'll be able to see these really well. And you may even be able to see some of the moons around Jupiter, the Galilean moons. Now, if you're just joining us, I've got a special guest here. If you're just joining us, welcome to the Branched Oak Observatory's live feed of the 2020 Great Conjunction of Jupiter and Saturn. This subtle but significant event is called a conjunction. And since the moon, the sun, and planets all move along this line called the ecliptic in the sky, upon the celestial sphere, we get to witness a few of these close encounters between various objects in the night sky throughout the year. Of course, this is just a matter of perspective, as they're all still quite distant from one another. Once depth is added to the equation, we can see that they're actually very far from one another. Astronomers call these apparent get-togethers between the moon and planets, multiple planets, and even planets and bright stars, conjunctions. But this is no normal conjunction. It is a great conjunction, which is not only between the two largest planets in the solar system, but with an incredibly small angular diameter or angular distance between the two. Now, normal conjunctions between Jupiter and Saturn are not that rare. They happen about every 20 years or so. Saturn takes 30 years to orbit around the sun. But since Jupiter is closer than Saturn, it takes a shorter amount of time. It moves faster in its orbit. It only takes about 12 years. So as Jupiter passes Saturn, which is what's happening right now, as Jupiter passes Saturn, it once again is able to catch up to Saturn, and that takes about 20 years for it to do so. And then we have another Jupiter-Saturn conjunction. But even so, because of their orbital inclination, they may be any number of degrees away from each other, apparent distance from 1/10 of a degree to a little over a full degree. Now, that's what makes this conjunction so special. That's what makes this conjunction a great conjunction, is because everything's lined up just right, that they are just 0.1 degrees away from each other tonight. And in this magnified view, you see a nice big distance between them. But if you go on outside and you look with the unaided eye, you will see how close these really do appear to one another. So again, going out, take a look. This is the closest that these two planets have been in 397 years. And if you miss it tonight, well, Oh, well, heck, you'll get another chance in the year 2080. I plan to have my consciousness completely transferred to a computer by that time, so hey, maybe we can have another live feed by then. If you're just joining us, welcome to the Branched Oak Observatory's live feed of the 2020 Great Conjunction of Jupiter and Saturn. Now, I've been talking for a while here, so I'm going to take a quick break and you can enjoy the conjunction in silence. And again, if you haven't already had a chance, be sure to go on outside, take a look in the southwest, and see if you can see these two with the unaided eye. I'll be centering and focusing our view here, and then I'll be back in just a couple minutes. Thanks so much for joining us. All right, I'm back. Welcome, everyone. Let's see. If you're just joining us, welcome to Branched Oak Observatory's live feed of the 2020 Great Conjunction of Jupiter and Saturn. We're trying to uh, maybe get a little faster internet speed going. I don't know if it's going to help at all, so I apologize if the video is coming through not very well, and also apologize if the audio isn't working. I haven't been able to actually check that out. So if the audio is an issue and it's kind of stumbling, you just turn off the audio and enjoy the live view here. Thought I'd give you some general conjunction information and facts about the planets. We've already outlined what a conjunction is and what makes it so special. But here's some further information for you. Now, right now, as we speak, Jupiter and Saturn are just 0.106 degrees away from each other in the night sky. They actually got their closest a little before noon today, which was viewable on the very, very western edge of the Greenwich time zone meridian. Portugal, for example, would have had an opportunity to see this. I heard that most of the UK, however, was completely clouded over, so they did not get a chance to see this amazing, amazing event. As I'm sure you all know, the close proximity between Jupiter and Saturn is just an illusion created by the orbital dynamics of the three bodies involved, Jupiter and Saturn, and the Earth, and the point of view in which we observe the planets. Although they look very close, the two planets are in fact far from one another, 456 million miles apart right now. That's about 5 times the distance between the Earth and the Sun. And in 10 years, when they are in opposition with one another, they will be twice that distance away from one another. So, once again, they appear to be very close, small angular distance, but they are extremely far apart, 5 times the distance between the Earth and the Sun from one another. If you're just joining us, welcome to Branched Oak Observatory's live feed of the 2020 Great Conjunction of Jupiter and Saturn. So let's talk a little bit about Jupiter here. Now, again, I mentioned it earlier. I know this video view is not wonderful. You'll have to forgive us. We're using a very, very powerful telescope with extraordinarily high magnification. And when we combine that along with with them being so low on the horizon, we're getting a lot of atmospheric refraction. So it kind of makes things a little bit fuzzy. Let me see if there's, maybe I can change this a little bit. That looks a little bit better, just a little bit better. All right, let's head back over here. All right, Jupiter. Big old Jupiter there is huge, isn't it? You could fit 11 Earths across of the diameter of Jupiter, and 1,300 Earths could fit inside of it. In fact, the remaining planets, all the planets in the solar system, volume-wise, could fit inside of Jupiter at the same time. That is big. Jupiter is also massive as well. The largest planet in our solar system is not only 318 times the mass of the Earth, it is 2.5 times more massive than all of the other planets in the solar system combined, including Saturn. That's amazing. Jupiter is the fastest spinning planet in the solar system, with a rotational velocity of 28,148 miles an hour. The planet takes only 10 hours to complete a full rotation on its axis. Yes, giant Jupiter rotates more than twice as fast as the Earth. That's incredible. With the outer atmosphere of Jupiter, that outer atmosphere that we see, the clouds, the belts, the zones, they are only half as thick as Earth's atmosphere. That always surprises people. That's right, all those beautiful whirling clouds and storms you see on Jupiter are only about 30 miles thick. They're made of ammonia particles floating in hydrogen and helium, broken into darker belts and lighter, high-pressure areas called zones. Below those clouds, the inner atmosphere is mostly hydrogen and helium all the way down. If you're just joining us, welcome to Branched Oak Observatory's live feed of the 2020 Great Conjunction of Jupiter and Saturn. Right now, we're talking about some amazing facts about these two incredible planets. That great red spot on Jupiter, it's been around for a very, very long time. Unfortunately, we wouldn't be able to see it in this view because at this magnification with this telescope and with the atmosphere, it's just kind of a big fuzzy blob here, isn't it? Every once in a while you can see a cloud band on Jupiter, but you'd be better served with a lower magnification telescope. You'd be able to see those cloud bands easily. But sometimes you can also see that great red spot. Tonight would be a no. But tomorrow night, if it's clear and you have a telescope, the great red spot will be visible the entire evening. So again, not tonight, but tomorrow night, if you have a telescope, check it out. You might get a chance to see the great red spot. A storm that has been raging on Jupiter for over 350 years. How do we know it's been raging for over 350 years? Because that's how long it's been viewed. It was first spotted in 1665 by an astronomer named Cassini. So that's pretty awesome. As big and as beautiful as the storm is, it does appear to be shrinking. Now, for the longest time, you could fit 3 Earths inside of it. It's actually getting a little bit smaller. So we're talking maybe about 2 to 2.5 Earths would fit inside of that giant cyclonic storm. Astronomers don't know if it's going to completely disappear or maybe it's just fluctuating and it's kind of getting smaller, and then once again it will get larger and larger. Some more interesting facts about Jupiter. Jupiter has rings. Yes, I know when people think of planetary rings, they think of Saturn, but in reality, all of the Jovian planets, including Jupiter, Neptune, and Uranus, along with Saturn, they all have rings. They're just not as, of course, extensive as Saturn's are. Even in this kind of lousy view that we're looking at here in our video view, you're able to see Saturn's rings there very nicely. How many moons does Jupiter have? Well, count, at last count, as of 2018, Jupiter has 79 confirmed and named satellites. However, it's estimated that it has well over 200 natural satellites orbiting it. But right now, we have 79 that are confirmed. The 4 major moons, known as the Galilean moons, named after the discoverer, Galileo, are Io, Europa, Ganymede, and Callisto. A really easy way to remember the 4 Galilean moons is I eat green carrots, or I eat green cheese, if you want to use that mnemonic. And the neat thing about that mnemonic is not only does it help you remember the 4 Galilean moons, Io, Europa, Ganymede, and Callisto. I for Io, E for eat, Europa, G for green, Ganymede, and C for Callisto, I eat green carrots, or I eat green cheese. It also is giving it to you in the orbit or in their distance from Jupiter, Io being the closest, Callisto being the furthest away. Ganymede, I eat green, so the third one furthest away from Jupiter out of these 4, is the largest moon in the solar system. It's 1.5 times larger than our own moon, and it's even bigger than the planet Mercury. That's right, one of the moons around Jupiter is bigger than a planet. Now, if you're just joining us, welcome to Branched Oak Observatory's live feed of the 2020 Great Conjunction of Jupiter and Saturn. Right now, we're talking about some amazing facts about Jupiter and Saturn, but I do notice that they are about to leave our view, so I am going to move over into the other room, try to get these back in the view a little bit here. So excuse me for just a moment. All right, that's a little bit better. And speaking of Jupiter's moons, Io, Europa, Ganymede, and Callisto, I'm going to go over to our camera software here. I'm going to slow down the exposure time, or actually increase the exposure time. It's going to brighten these out, blow these out a little bit, but here we'll go this way. We may be able to capture some of the moons around Jupiter. So again, it's going to blow. Oh, there they are. There's a couple of the moons around Jupiter right there. Let's see if I can blow that out even further. Oh, there's another moon appearing. And I'm not catching. Let me see if I can make this even longer. Yeah, just not catching the moons around Saturn, though, am I? But we can easily see the moons around Jupiter. I'm going to once again change this so it looks a little bit better. And we say goodbye to the moons, unfortunately. And how does that look? That looks pretty good. I'm going to change this a little bit because I think it looked better here. I'm going to try one more little thing here. Yeah. It's going to try some live stacking, but nope, don't think that works. So we're just going to go back over to this mode here. I know the view isn't wonderful, but we kind of explained that, and I'll explain that again a little bit later. All right, let's head on back over here, and let's talk a little bit more about old Saturn there. Saturn is huge at 9.5 times the size of the Earth. It's the second largest planet in our solar system. Jupiter is the only planet that's bigger. Saturn's rings, however, extend out 175% the diameter of Jupiter, making Saturn even bigger, well, if you count the rings, that is. Like Jupiter, Saturn is made mostly of hydrogen and helium. It is, however, less dense than Jupiter by about half. In fact, Saturn, on an average, even including its rocky core at the very center, is less than the density of water. Yes, Saturn could float if you had a big enough bathtub, I suppose. Saturn, at last count, has 82 moons. Wait a minute. Jupiter had 79 moons. That's right, Saturn has 3 more moons than Jupiter. For the longest time, Jupiter, the largest planet in the solar system, had the most moons, or the most known moons. But just recently, Saturn beat it, and Saturn now has at least 82 discovered and named moons. Now, while Jupiter has the largest moon in the solar system, Saturn has a pretty big one too. Its name is Titan. It's the second largest moon. So the largest planet in the solar system has the largest moon in the solar system. The second largest planet in the solar system has the second largest moon in the solar system. So that's easy to remember. Now, although Saturn has 82 official moons, if we look very closely at the rings, we will notice that they're not solid, but rather made up of billions and billions of little icy dust and rocky-like particles. Each of them, each one orbiting Saturn like a little tiny moon. Saturn's rings are extraordinarily thin. Although the rings span 180,000 miles in diameter, that's 3/4 of the way to the moon, by the way, they're only, on an average, about a half a mile thick. They actually range everywhere from 2 miles thick all the way down to only about 30 feet in thickness. That's incredible. Comparatively, if Saturn's rings were the size of a regular sheet of paper, just a little 8.5 by 11 sheet of paper, if the rings were that width, the thickness of the rings would be 100 times thinner than the thickness of a sheet of paper. Now, I've been talking for a while. I'm going to take a quick break so you can enjoy the conjunction in silence. I'll be off. I'm going to go ahead and center these a little bit. We'll see if maybe I can focus it a little bit, and I'll be back in just a few minutes. Thanks, everyone, for joining us. Hello, everyone. So you might be wondering, why does this image look so lousy? Well, we mentioned this a little bit before. It has to do with the extremely long focal length of the telescope that we're using. But now these two are getting very, very low on the horizon. Well, at least low for us. As a matter of fact, they are going to start to be peaking beneath some trees here, our tree line out at Branched Oak Observatory. But I'm going to go ahead and go as long as I can see the two planets. So let's go ahead and talk a little bit. If you're just joining us, welcome to Branched Oak Observatory's live feed of the 2020 Great Conjunction of Jupiter and Saturn. We are indeed live from the Bowler Civil Observatory at Branched Oak Observatory Sky Park, viewing the planets Jupiter and Saturn through a 2,800 millimeter 11-inch Schmidt-Cassegrain telescope. And again, you'll have to forgive the poor imagery here. This is a live view. It's not stacked. It's not a processed image. Also, with the planets as low as they are, especially now, we're getting a lot of atmospheric refraction, which is compounded by the magnification that we're using. If you have a telescope, it is undoubtedly going to be a shorter focal length, and you will get a more appealing image. So get that on out. Take a look at Jupiter and Saturn, and you may have a chance tomorrow as well to check these out. They won't be quite as close, but pretty darn close to this. So if it's clear where you are and you have a telescope or binocular, set that up. Now you know what it looks like. And this really brings us to a very important recommendation. If you have not already taken a look at the pair with the unaided eye, please go outside and do that. It's important that you see these two with the unencumbered eye live. Let those photons hit your pupil. And don't be surprised if you tear up just a little bit. Doesn't happen to me. I just sometimes get a little something in my eye. But for other people, it might happen. Seeing nature's celestial dance can do that. And it's common with eclipses and planetary transits and maybe even great conjunctions like this one. It really is incredible. If you have clear skies in your area, the two planets are low in the southwest. They're probably, I'd have to look. I think at this moment we're talking about 7 or 8 degrees above the horizon, but you really can't miss bright Jupiter. And Saturn may be difficult to resolve at first because Jupiter it's 11 times brighter than Saturn, and it'll be lost in the glare. But when you look closely, you'll see, aha, there's a little tiny star next to Jupiter, and that is it. That's Saturn, right next to each other. In this somewhat lousy view that we're looking at here, that looks so darn blurry, you can see there's a little bit of space in between the two, but to have the two in the same field of view in a telescope is really, really exciting. And together you'll be able to see those. If you're just joining us, welcome to Branched Oak Observatory's live feed of the 2020 Great Conjunction of Jupiter and Saturn. These two planets for us out here at Branched Oak are just about ready to go behind the trees. As a matter of fact, I'm thinking that's why this image is looking the way it is because I'm probably looking through some branches. But I'm just going to keep on going until we can't see these anymore. And I have a sneaky suspicion that's not going to be much, much longer. But again, it's still high in the sky, high enough that if you haven't had a chance, go on outside and take a look. This subtle but significant event is called a conjunction. Now, since the sun, the moon, and the planets all move along the ecliptic upon the celestial sphere, we get to witness a number of these close encounters between various objects in the sky throughout the year. Of course, this is just a matter of perspective, as they're still quite distant from each other once you add depth into the equation. Astronomers call these apparent get-togethers between the moon and planets, different planets, even planets and stars. We call these conjunctions. This, however, is not a normal conjunction, is it? This is a great conjunction, which is not only between the two largest planets in our solar system, but they have an incredibly tiny angular distance between the two. They are extraordinarily close. Now, normal conjunctions between Jupiter and Saturn, normal conjunctions, they happen relatively often, well, every 20 years or so. Saturn takes 30 years to orbit around the sun. 30 years. We take 1 year. Saturn takes 30 years to go around the sun. But since Jupiter is closer to the sun than we are, it moves much faster. Jupiter only takes 12 years to orbit around the sun. And because of that, when Jupiter passes Saturn, which is happening right now, as Jupiter passes Saturn, it's able to orbit completely around and then catch back up with Saturn again. And this takes about 20 years. And that's why we have a conjunction between Jupiter and Saturn every 20 years. But even so, because of the orbital inclinations of the two, they can be a variety of angular distances away from each other, from 0.1 up to, well, a little over a full degree away from one another. And that's what makes this great conjunction so amazing. It's what makes it great. These two are only 0.1 degrees away from one another. This is the closest they've been in 397 years. So again, get outside, take a look. And if you miss it, that's okay. We have another one in the year 2000, 2080. Oh no, I probably won't be seeing that one. I hope to have my consciousness transferred to a computer by that time, and maybe then we'll get to have a live feed once again. Oh boy, there it goes. Yeah, you can see the telescope is having a really hard time seeing these. So if you're just joining us, welcome to Branched Oak Observatory's live feed of the 2020 Great Conjunction of Jupiter and Saturn. Unfortunately, we've only been able to view this for 1 hour here from where we are because Jupiter and Saturn are dipping down below our tree line, and that's why we have just big piles of fuzz now in this video. They are diving into, I'm actually looking through tree branches as it is. So tell you what, I think it's time for us to probably call it done with our live feed, but I will tell you, the camera that we've been using here is really not a planetary camera. It's made for doing much longer exposures, and the software is made to do live stacking, and it can produce some incredible imagery. The reason I bring this up is that we do plan in the future, particularly because of COVID-19 right now, we do plan on having some live from Branched Oak Observatory virtual star parties. And we'll look at deep space objects, galaxies, nebulas, and star clusters. And if that's something that interests you, be sure to let us know that you would like to see that. And maybe we'll plan a few in the future. Well, those of you that have joined us for our live view of the Great Conjunction, I'd like to thank you so much for seeing us. This is our very, very first live feed here from Branched Oak Observatory, and hopefully we'll do many more in the future. Thanks so much, everyone, and we'll see you next time.